What are AI models? Don't worry, we've got you covered. It's time for another ctrl+alt+ai. All right, so there are lots of types of AI models, but in general, their goal is to autonomously make decisions or create predictions without human intervention. Some of the first AI models were written back in the 1950s to play chess and checkers. These models would make moves based on interactions with a human opponent rather than like using a predetermined set of moves. Models today will use algorithms applied to an input or prompt to make a decision or create an output that it's designed for. But we used a new word there, algorithm. And while some people will use model and algorithm interchangeably, they're not exactly the same thing. So let's dive in and explain why they're different. First, let's imagine that a model is a sandwich chef. And given your input or your money in order, it will give you the sandwich you requested. But an algorithm is used to train a model, and it has all the decisions the model needs to make on your input to generate the correct output. So, in the instance of our sandwich chef, it has all the logic to say, given your order and your money, is this enough money for that order? How much change should you get back? What ingredients are required, and in what order should we be putting them on the sandwich? Wait, what? Let's get back to models. Now, AI models can be used for decision making, but only machine learning models are capable of improving their performance over time by themselves. But we again used a new term, machine learning. If you're not familiar with the term machine learning, well, we can show you a video that we've already done that shows you the difference in artificial intelligence, machine learning, deep learning, or even generative AI. Click up there in the cards if you want to learn more about that, but we're going to stick with models here. Now, while all machine learning models are AI models, not all AI models are machine learning models. In fact, the most basic AI models are just a series of if this, then this, else this, rules that are programmed by data scientists. In fact, we actually call them rules engines or expert systems or symbolic AI. But machine learning uses statistical AI. And I know, there I've gone again using weird terms like symbolic AI and statistical AI. But without getting too far into the weeds, let's just say that machine learning models use their algorithms applied to a data set, and that data is mapped out and plotted, and we find groupings of similar and dissimilar things. Then that plotted data is used and compared to the inputs we give it in the future. Now, from here on, I'm going to specifically be talking about machine learning models. So even though I'm just going to say models, understand we're just talking about that one specific type of model. Now, there are several different ways to categorize models, but one of those is based on the way it learns. And that's normally as supervised, unsupervised, and reinforcement. Let's explain what that means, starting with supervised. Now, with supervised learning, we need labeled data. What is labeled data? Well, let's pretend that we're building an image recognition model that'll determine the difference in hot dog or sandwich. That data might look like this, where we'd have to label every record with sandwich or hot dog. But we'd also probably want to provide some other key indicators like the width or the height or the type of meat, all things that could inform those primary labels. Now you can imagine with that example, we're wanting a right answer or a wrong answer. It is a hot dog or it's not, or is a sandwich or it's not. But unsupervised learning models don't think in terms of right and wrong. And that's why unsupervised learning models don't need labeled data. In fact, their algorithms just look at that data and detect patterns or groupings of like objects. But when would we want information that's not just right or wrong? Well, a great example will be a recommendation engine. Let's look at that data again and remove the type column. Now, when our algorithm looks at that, it's going to plot those things and find the things that are similar. So if we provide as an input maybe what we had for lunch today, it could find and plot that information in that world and say, hey, we think based on that you want something like this, and recommend a sandwich that I might also enjoy. Now, the last learning method is reinforcement. And in reinforcement learning, a model learns by trial and error. It does this by rewarding correct answers and penalizing incorrect answers. Now, I'm going to be oversimplifying this a bit, but let's imagine that I have a dog that I'm trying to train. And I take it to a room that has 2 plates in the floor, one with a hot dog, one with a sandwich. Of course, I would never want to subject anyone to a hot dog. So anytime it goes and chooses the sandwich, I reward it by saying, good boy. And every time it goes to the hot dog, I tell it no. Over time, the dog learns, hey, sandwich good, hot dog bad. So how does that look in the real world? Well, imagine social media posts. As you are recommended a new post or a new advertisement, if you downvote something or dislike it, it's going to be penalized, and it's going to feed back into that algorithm that says, hey, don't show them that kind of stuff. Similarly, here on YouTube, if you were to hit that like button right now, the algorithm's going to get fed back a reward and say, hey, that person likes that kind of content, continue to show them that sort of stuff. Now, another way we use to group models is the method they use to predict outputs. Those groups are generative and discriminative. Now, don't be scared by those terms. We'll simplify it. In most cases, generative models are using unsupervised learning, and in most cases, discriminative models are using supervised learning. The definition that defines whether a model is generative or discriminative is how that model maps its data in a given space. Modeling data in a given space, what the what, Michael? You're using those terms again. I get it. Generative algorithms model the distribution of data points. Their goal is to predict the probability of a certain point living in a particular space. For instance, in our data with the hot dogs and sandwiches, the model could be identifying correlations like hot dogs seem to only have one piece of bread, or the sandwich seems to have lettuce more often. Those predictions can be used by the model to generate outputs that it thinks are probable. So imagine a model trained on text data. At the basic level, we could use it to predict what level is going to come next, like on an autocorrect. Or at a massive level, we could use it to create whole new sentences, paragraphs, or even documents. Does that sound familiar? Yeah, we're using that anytime we use AI to create text for us. And we're also using it for things like translation and code generation. So if that's generative models, what are discriminative? Well, I'm glad you asked. Discriminative algorithms model the boundaries between classes of data points. These boundaries are called decision boundaries. They attempt to predict the probability of a given data point falling in one of those classes. Now, going back to our previous example, a discriminative computer vision model might distinguish the difference in hot dog and not a hot dog based on the fact that if it's delicious, it's not a hot dog. I'm kidding, it doesn't know how a hot dog tastes. But it might recognize patterns like if it's longer than it is tall, it's a hot dog. These boundaries allow it to ignore correlations that a generative model might have to take into account. And they also make discriminative models amazing at classifying data. You know, it's important to note, though, that discriminative and generative models can often do the same tasks, though in some cases one might be better than the other. But that's why AI systems often use both in tandem. In fact, like a natural language processing or NLP AI may use a generative model to write some text out, but it might use a discriminative model to then translate that text. All right, well, there's one more way to group models, and that's based on the type of tasks they perform. Now, most models fall into either classification or regression. And I say most because some models are able to do both. In fact, most foundation models are able to do both. Now, if you're not familiar with foundation models, click that card up there and you can learn more about those, but we're going to continue on with models right now. Okay, so let's start with classification models. These are great at predicting discrete values. Think yes and no. Or some recommendation engines will use them to predict whether a category is A, B, C, or D. Now we're hitting all of these at a really high level. Like within classification, you've got things like linear discriminant analysis or logistic regression, but that's way too deep for what we're doing today. But don't worry, we're going to do videos about those, so if you want to see them, be sure to hit that subscribe button so you don't miss. Let's move on to regression models. Regression models are great at predicting things that have a continuous value. Think like time or age or price. They're good for finding the relationships between one or more given inputs and a dependent output. So given X, predict Y. Or in our example, if I give you the last 5 sandwiches I've eaten, predict the next one I'm going to eat. All right, take a breath. We've covered the way we think about AI models and group them. But there's still a lot more to cover, like how do you train a model? What is this bias thing I hear about? What is fine-tuning? We're going to get to all that, but I'll be honest with you. All this talk of hot dogs and sandwiches has got me a little hungry. Hey, if you like this video or perhaps you learned something, do me a solid and hit that like button below. And if you've got any questions about models, deep learning, or anything AI related, Leave it in the comments and we'll be sure to cover it. Until next time.